How's it going, everyone? Eulier Gonzalez here again, looking at the React Performance course taught by Steve Kinney, head front-end engineer at Temporal, this open source durable execution platform that you can think of this pretty much like Kubernetes that allow you to orchestrate containers to cover a specific business use case. So today's video we're going to talk about is this escape hatch section from learn model in React Dev as a way to not only improve our communication skills, but when we need to explain this kind of complex topics, make it meaningful not only for our colleagues, but also for those who are not tech savvy, the business people, users, shareholders, your mom, grandpa. The idea here is that when you are able to do this, you are now capable of truly understand something. So if you can explain that to your grandma and your grandma can understand that, that's great. If you can talk that also with a colleague in this highly technical detail and they can understand that, that's great. You have now the capability and the flexibility needed when it comes to explain complex topics. And that's one of the role of the senior developers, or I will argue that senior citizens, that giving all of these complex topics, they can make it meaningful to others. So that's the reason why I'm actually recording this series of videos as a way to not only improve my technical communications, specifically with React, but also how now we can combine, or in my case, how can I combine, and you can listen to that, how all of these different concepts from not only React, but also in JavaScript, in data structures, in computer science concepts like algorithm and data structures, combined together as a way to make sense of how do we get here. And also put at practice what you have learned. So, because theory without practice is useless, and practice without theory is not replicable. So here we are. Okay, so again, the goal of this course is to see how can we write React performance in the most performant way. So Steve Kinney provide us is some sort of toolkits as a way to, when we need this kind of issues, follow this particular recipe here or these guidelines here. So because in performance, part of the introduction here, the value proposition of this is, especially in React, is it is much faster not doing stuff than doing it. And there's some corollaries that you can come with. So it is way faster to do things later on than doing today. So because of that, and we need to learn about how React actually works behind the scenes as a way to then look at the performance issues, and when you encounter that, you can come up with and you can develop a tool set that allows you to identify those problems and come up with some sort of solutions, best practice to that. And I think this is something important, not only in the React context, but also in life in general. If you truly want to optimize something, you really need to know the mechanism of that. So whether it is in your fitness, whether it is in your nutrition, whether it is in your car or motorcycles, in your profession, you need to understand that first, and all of it is inner mechanism, concept, and how do we get here. So now you can find a way to optimize that. That is what you want. I will use the example of nutrition and health, as well as which is something that I need to do, the sleep, because now this is some problems that we all share in common. And given this society that we live in right now, society of masses, and combined with technology, we are now facing challenges that none of our ancestors will ever imagine that. So we are on our own. We are on our own right now, but because all of us share these particular problems, we can come out with some sort of practice, some sort of behavioral tools. In any case, so, well, to understand now React, we need to look at or I'm going to take a look at a quick recap of all of this, all right? As a way to now be able to describe this in the most precise possible way. So, the React, after all, is this JavaScript framework that allows to describe UI. The way how you can describe your UI in React is using JavaScript functions. And JavaScript functions is the first citizens class. The first citizens in the language. And by first citizen, it now has the ability to not only you call this function, but also to store them under the prototype. So this is something that is important to understand, that I know this is go beyond the scope of React, but if you're able to describe that and to understand that, for example, that in JavaScript everything is an object, including functions, and functions are just a special type of objects, okay, where we can call them as a way to run this set of instructions, and we can allow us is to store some information as well in the object shape under the prototype, okay, and how now JavaScript, the way of how can it access property and methods or inherit is through the prototype chain. You may wonder why this is important. Well, because this is now how JavaScript, or how an object, and when we talk about object, is this object-oriented programming, which is how can we now organize our data and its current functionality in one single bundle using an object. You may wonder why. Because back in the 60s, people wrote those programs line after another in blocks, and it was quite hard to actually combine or having one single place the data and its functionality. So they need to look in another file, or they need to look at in another line of program. So it actually is not readable. So because of that, we use objects as a way to represent that. And that's the reason why we are using objects, and as a way to now have access to other property and methods to make them reusable, pretty much like your grandma or grandpa. Anytime he finds stuff in your house, he say, "Hey, no store here," or even your mom or your dad. He said, "No, leave it here. Store this here." We never know when we can use it. You know, it's trying to be reusable. It's trying to reuse some of those data and property. The way how can we do that is through the prototype change. And again, okay, so back here, describing the UI. So we look at the React components are functions, JavaScript functions. We look at how can we import and export those JavaScript functions, aka React components. How can we use this markup language which is JSX, which combined is JavaScript with HTML, and how can we now connect that through the curly braces as a way to anytime we detect an event from the HTML, we can trigger is a handler on the JavaScript part, as well as how can we now is pass props to these components. Okay, how can we how can we conditionally render components? How can we render in list of components using is the key as a way to notify React, hey, I want you to keep track of this for me. So pretty much like you have a folder with all of this file. If you know how to keep track of them, it'll be horrible. It's like you never know what went wrong or what happened. So after that, also we look at the importance of creating is your functions, your React components in a pure way. Meaning is that that functions that don't cause any side effects. So meaning that giving the same input, we always get the same output. The reason of that is that it allows these functions to run in any JavaScript environment, whether it's on the browser, the server, workers, as well as we can now catch this React components using memorization techniques. Hey, I want you to prevent the React actually render this, aka compute these functions. And also when you are which is here, for example here, it is completely fine to change variables and objects that you just create while rendering. Where you can cause side effects. Well, functional programming rely heavily on purity. At some point, somewhere sometimes has to change. That's kind of the point of programming. These changes updating the screen, starting an animation, animating are called side effects. There are things that happen on the side, not during rendering. React side effects usually belong inside of the event handlers. Event handlers are functions that React will return when you perform some action. That's right, so event handlers don't need to be pure, but your React components needs to be pure. Okay? If you're exhausted of all of the other options and can find the right event handler for your side effects, you still attach it to return GSS with use effects, which is something that we're going to see that later. Okay? This tells React to execute it later after rendering, when side effects are allowed. However, this approach should be your last resort, even though here it tells you when it needs to be done. And why does React care about purity, right? So, now give me a second. And we are back. But again, this is now to describe is that keeping your component pure. For example, like purity, okay? It minds you its own business, single responsibility, and same input, same output. The TLDR of that. Right, side effects, unintended consequence, for example, like that. detecting impure calculation with strict mode, like this. But the problem is that it's actually triggered, it actually re-render, meaning it's computing your component twice. So if you're using a strict mode. Also, you might not have used them at all. In React, there are three kinds of inputs. You can read while rendering: props, state, and context. And there are three kinds of inputs that you can read while rendering. So during execution, there are three kinds of input that you can render: props, states, and context. And you should always treat this input as read only. So when you want to change something, when you want to change something in response to user input, you should set the state instead of writing to a variable. You should never change pre-existing variables or objects while your component is rendering. Meaning that if you're going to update that, you need to notify to React to do that. But you never change props here. So React props are read only. So React offers a strict mode in which it calls each component functions twice during development. This is one of the reasons perhaps you might not want that, because it becomes quite annoying to actually, especially if you are having, if you're calling the APIs twice, it's actually quite confusing there. But the idea here is that with the strict mode, they want to guarantee that you are not performing is side effect, or that you're So by calling the functions components twice, strict mode help you find components that break this rule. So when you change when you want to change something in response to user input, you should set state instead of writing to a variable. You should never change pre-existing variables or objects while your component is rendering. In other words, is that to make sure that you actually is you mutating the state in the proper way. So notice how the original example display gets 2, gets 4, and gets 6 instead of gets 1, gets 2, and gets 3. For example, here. The original function was impure. So call it twice broke it. Because you are mutating is the state as you're getting here. So in other words, is you can is defined inside of that. Local mutation, your component little secrets. Okay. So when they're going to tell you, hey, what this strict mode actually does, okay, pure functions only calculate, so calling them twice won't change anything. So the strict mode is a way to check that you don't break the rules of that you It's just a way that your component is not performing side effects. Okay, that you always get the same value giving an input. So given the same input, you always get the same value. So anytime it renders your components, or calling your components, you always get the same output. Or in this case, you also generate is the same GSX, like that. So okay, and also we look at why does React care about purity, right? Because if some data in the middle, of the rendering, in the middle of a rendering, a deep component tree, React can restore rendering without wasting time to finish the outdated render. In other words, if React is now calculating all of this, so if some data changed in the middle Mhm. If some data change in the middle of rendering a deep component tree, React can restore rendering without wasting time to finish the outdated render. Purity make it safe to stop calculation at any time. So no matter what data change happen, okay, if some data change in the middle of the rendering of a deep component tree, React can restore rendering. Mhm. React can restore rendering without wasting time to finish the updated render. So every new React feature we're building take advantage of Purity, from data fetching to animations to performance. Keeping components pure unlock the power of React pattern. Again, we are quickly describing here, and also the strict mode, as well as the white. Yeah, the strict mode is guaranteed that anytime you that React render this component, it will always get the same GSX. In other words, that your component doesn't perform any side effects, which means that your component must have it is my own their own business. It must return is it must be pure. So must given the same input, you always get the same output. That's all. So why is that important? Okay, and why now state strict mode guarantee that? So strict mode guarantee that as a way to anytime it re-render, as a way to anytime React re-render this component, it can do that in a way that always return is the same GSX. Why is this useful? Okay, well, because if we create our components in a pure way, after all this JavaScript function, if we create our components like that, we can now is guarantee that this function will work in any environment that run JavaScript, of course. So for example, on the server, since they return the same result of the same input, one component can serve many user requests. So since they always get the same, okay. So for example, the server, since one components always get the same input, we can serve many users requests. That's one, and that's beautiful. Okay. The other is that you can improve performance by skipping rendering. Using is some of the built-in catching techniques, or catching some of the using some of the built-in React hooks. So like use callbacks or use memo. Use memos allow you to skip or to catch computation between rendering, whereas use callback allow you to catch function reference between rendering. So React don't need to actually go through that, and instead it say, all right, let me now is skip that unless you have something in your array of dependency that indicate to React, indicate to me, hey, I need to go through all this. But enough. Okay, so we'll describe is the reason why we need to create our components in a pure way. Okay. And what is this strict mode allows to do. So then we can until the end is that, well, a component must be pure, meaning that mind its own business and same input, same output. Period. So then we look at the UI 3 as a way to understand now how React sees our components. Okay, so this 3 data structure which come from the data from the computer science as a way to organize our data, something that I already mentioned, by the way, and where you have now arrays, hash maps, linked list, double linked list, tree, and graph. All of these are way of how you can organize your data to help you for a specific use case, or to help you to solve a specific to help you solve a specific use case, to help you solve a specific problem that you have. For example, your fridge is good at preserving foods, right? So you can put fish, or you can put fish and ice creams. And your backpack is good at help you to organize some other stuff. For example, you can put your tablet, iPhone, iPad, some notebook, pencils, keyboard, mouse, So you swap that, or if you swap that in your fridge, so instead of storing is in your backpack, storing in your backpack is fish or ice cream. Again, it's gonna depend on for how long you want to keep that. The TLDR of this is that this structure serves you to cover specific use cases. And then how you can combine them as a way to solve these particular problems is when we're going to see that later on, but not in today's video. Here we're looking is that now how the UI render tree works, okay, as a way to now allow the where are the HTML tags in the render tree? So you'll notice in the above render tree there is no mention of the HTML tag that each component renders. This is because the render tree is only composed of React components. React as a UI framework is a platform agnostic. On React Dev, we show examples that render to the web, which use HTML markup as UI primitive. But React could just as pure, but a React app could use as likely render to a mobile or desktop platform, which may use different UI primitives like UI view or framework elements. These platform UI primitives are not part of React render tree that can provide insight to a React app regardless of which platform you are rendering. And it's because framework element class provides a WP framework level set of property, events, and method for window presentation foundation, which means that window presentation formation. For Windows or for app? Okay. For Microsoft or Apple. The UI here. An object that manages the content for a rectangular area on the screen. Views are fundamental building blocks of your app user interface, and the UI class defines the behavior that are common to this. But again, this platform UI are not part of React. React render tree can provide insight to a React app. But the thing is that you notice in the above render tree there is no mention of HTML tag for each component render. This is because the render tree is only composed of React components, like this. So React as a UI framework is platform agnostic. So, and because after all the React DOM render, or React itself, so React itself is the developer surface. Okay. And because of that, is platform agnostic. On React.dev, we show examples that render to the web, which use HTML markup as UI primitive. But a React could also likely to render to a mobile or desktop platform, which may use UI primitive like UI view and framework. That's one of the reasons why React, after all, is this developer surface, where now you can combine with any other rendering. It can be the root, the DOM, React DOM, the React DOM, for example, like this, which is the React DOM components, APIs, client server. Exactly, components of React DOM. React DOM APIs. For example, React DOM API client, okay, as a way to allow you to use this and the server, allow you to render those. So because these docs, look at this. So because these docs focus their attention, okay, because these docs focus their attention is on the DOM, okay, React per se is platform agnostic. So you can think of React as this developer surface where you can use is different rendering mechanisms, something that actually Brian Hall described. You can use the React DOM as a way to work with the browser and the server. You can work is with the React native as a way to work is with the Android and the mobile, the Android and the iOS. You can also use is for desktop applications or for React 360. But again, the idea here of those software developers in React, in Facebook, now Meta, formerly Facebook, is that we have now this set, okay, we have now this developer surface where we can now interact to whatever elements we need to. We can interact to whatever platform we want is to actually create this UI element. And that is quite fantastic. That's quite interesting. Because now this enable is not only to build is on the web, but also on the browser. And in the case of the browser, is because here is where the attention are right now. So understand this, okay, especially when we look at how can we, or how now React sees our components, okay, as a UI 3, okay, and why, after all, React, at least from the webs, why React is this platform agnostic? It's a UI, okay, it's a UI framework. It's a platform agnostic UI framework that we can now work with different of this platform that I mentioned, okay, which makes them great. In our particular case, we're looking is at the web, okay. So when we take a look at the render tree, which is here, and the model dependencies, okay, another relationship in React that can be modeled is a tree. With a tree are apps model dependency, as well as breakout components logic. So a logic into separate files, we create GSS models for that. Each node in a model tree is a model, and each brand represents an import statement in that model. Which means is that, hey, this particularly, if we take a previous inspiration app, we can build a model tree dependency of this, where now the entry point apps import the inspirator generator, where it has the fancy text, color, and inspiration, followed by the fancy text and all of this. So the whole point of this, okay, these dependency trees are useful to determine what models are necessary to run your React app. So when building a React app for production, there is typically a build step that we will bundle all the necessary JavaScript to ship to the client. The tool responsible for this is called a bundler. And as your app grows, often the bundle size does too. Large bundle sizes are expensive for a client to download and run. Large bundle size can delay the time for your UI to get raw. The key idea of this is that once we look at the UI and how React see these components in a tree data structure, which is coming from these computer data science concept from data structure as a way to organize our data, and how can we interact with that, how can we access, remove elements or insert elements, and how now React is a UI framework agnostic that allow us is to write this UI in the on the desktop or on the mobile, as well as on 360. For example, we have now renderers that are capable is to, given this developer surface of React, now we can actually talk to those platforms and render those elements. So this is something great, but the practice is that is quite more elaborate, and you need to actually dedicate your time to this and put up practice any of this concept. Also, we look at the concept of the tree dependency, or the model dependency tree, which is, well, anytime you import any utility function or JavaScript function that a particular component needs, so it is useful to see what is the necessary code that this React application needs to show something to the user. So we use bundlers, or we use bundlers like Webpack or Vite that allow us to do that. So once we are able to describe is the UI, okay, how now can we do that in React? We also look at how can we now add interactivity to this UI element, which is, after all, if we're not, we're just writing is plain HTML. So the way we can do that is through the event handlers. And when you now show some data, for example, in your bank accounts app, you want to see is your balance, followed by the transaction history and the credit card history, that kind of thing, you know. So the way of how can we show data that come from the server and show them in a way that this component remember things is by using states. So state, you can think of this as a closure. Behind the scenes, the using is a closure. Okay. So that's quite interesting. That's quite fantastic, by the way. Yeah, that's quite interesting. That is quite fantastic. Because now, once we look at how can we make this component to remember things using closure behind the scenes, which is a JavaScript function, which is a JavaScript bonus features. We're going to talk about that later. But the idea here is that once we're able to look at this, and how can we use state as a way to remember things in our components or data in our components, when we need to update that state, we do that by using a setter function. So When you update your state, now React pass through this rendering mechanism, pretty much like an assembly line what you got there. So the first element or the first phase is the trigger, the second the render, and the third is the commit. And there is an epilogue that we're going to talk about that. So first, trigger is going to detect that when this state update, it was part of the initial render at the root element, or it was caused by a component whose state update, or it was caused by a component or any of its ancestors that trigger a state update. Then move on to the render phase when it's going to look at, is this triggering happen at the initial render at the root element? I'm going to create the element for that using the create element method from the document. If it's not, if it was, it was caused by a component, React will call the component that trigger that state updates. Is going to calculate all of this props, event handlers, in state. You're going to store that information that we're going to use in the next phase, okay? And the output of that function, if that return more React components, it will call that in a recursive way until it reaches the end of the tree. So now once React knows and compute all of that information, okay, it is time for them to actually apply the necessary state change to commit those changes to the DOM. If this happening at the root element, so React we're gonna use the append on API and put all of the elements in the DOM. If this was caused by a re-rendering, it will check now if there are a difference between render and apply the necessary change updates. So the epilogue is, once the browser detects those DOM updates, then it's going to repaint your, then it's going to repaint that. So rendering must always be a pure calculation. Same input, same output. It minds its own business. And optimizing performance, you can also avoid to re-render this as a way to optimizing performance. But that's quite interesting. So this works because this last step, React only updates the content of H1 with the new time. It seems that the input appears in the JSX in the same place as last time, and React doesn't touch the input or its value. So once we are able to describe that, okay, and what's going on behind the scenes, when it comes to understand how state works, like regular JavaScript, they behave quite different. So because now anytime you set a state, it triggers a re-rendering. And how we can think of state as a snapshot. As a snapshot during rendering, which means that when you are setting your state inside of your event handlers, you can see that the React keeps that state inside of your event handlers within the that React keep the state within the current event handler render. So what does it mean? That is that when you are going up, when you are about to set the state in your event handler, so React taken a state snapshot, okay, of that information. Your state's value will change in the next render, and when you're working with the states inside of your event handlers, React will keep or will fix that state for you during the event handler's state, during the event handler's rendering. So why this is important, okay? Because now states are used as a state at the time of the render, okay? So when now React hold this state act as a snapshot, as a way to now being used during the rendering phase. And if you update the state during that phase, it will be available in the next render. So all of this is just as a way of how now can we take a look at describing the UI, and then how can we add interactivity? How can we add interactivity through the event handlers? How can we now set the state as a way to show information on the UI components? And then how can we now update the state as a way to show relevant data to the users? What's going on when we do that, which is the rendering mechanism, the trigger, render, in commit phase. And lastly, now the browser detects all of those changes and then render the UI. And how, when it comes to think with this, and when it comes to work with the state during the rendering phase, think of them as a snapshot, state as a snapshot, as a way to, anytime that React is rendering the components, evaluating the JavaScript function. Okay, now it has this state fix, or it has this state per rendering. So this state update the state change value will be available in the next rendering. And when you want to set the state, you can do inside of your event handlers, you can think that React fix the state value there. And also, when you want is to now update is your state, let's say patching is a series of state updates, series of orders to React inside of the event handler, you can use the arrow function as a way to do that. This is very narrow specific. Sometimes this is what you want, okay? As a way to trigger is a state update within that render, and then with the next value you want is to reuse that state. A good example of this is when you're defining a good example of this is when you define is the, how do you put it? A good way of this is when you define is inside of your event handlers and trigger some async functions. Okay, remember, after all, your event handlers can be can perform side effects, but your function, your React component, should not. In any case, here is now the way of how we can update our state. How can we updating a series of state updates. We also look at how can we update how can we update objects and array in a state. The TLDR of this is that always return is a new always return is a new state. Exactly. So treat any JavaScript object that you put in a state as read only. And if you want to now update that, you set that. So create a new object and pass it to a state setting functions for that. Local mutations is fine. And then you pass. In fact, it's completely equivalent to writing this. Mutation is only a problem when you change existing object that already is in the state. And then copy here, copying exactly data structure here. And as a way of how you can use this as a spread operator to do that. Quite interesting, because after all, the object spread operator, what it's doing is to copy and merge objects here. It's going to say, hey, all of the key value here will be spread across this. Note that the spread syntax is shallow. It only copies things one level. This makes it fast, but it also means that if you want to update nested property, you will use it more than once. So using a single event handler for multiple fields for that. Updating a nested object like so. So the TLDR of this, okay? Objects are not really nested. Objects like this appear nested in code. However, nesting is an inaccurate way to think about how objects behave. When the code executes, there is no such thing as nested object. You're really looking at two different objects here. Okay, nesting up. Okay, so nesting is an inaccurate way to think about how object behaves. When the code executes, there is no such thing as a nested object. You are really looking at two different objects. One of that contains is the name and a reference to the artwork. Exactly. So the object 1 object is not inside of object 2. It's just a reference. It points to that. For example, object 3 could point at object 1, because now you're talking about its reference. If you were to mutate the object 3.add_work and city, it will affect both. If you mutate the object 3 artwork city, it will affect, exactly, if you mutate the object 3 artwork city, it will affect is the object 2. If you were to mutate the object 3 artwork city, it will affect both the object 2 and the object 1 city. This is because object 3 artwork and object and object 1 are the same object. This is difficult to see when you think of object as nested. Instead, they are separate objects pointing to each other with property. I think this clarification here, what we are now talking about, is updating object in a state, and why we need to always is return is a new state and avoid any deeply nested object, which is just an inaccurate way to say they are pointing they are separate objects pointing each other's property. And I want to make a quick pause here, because pretty much similar to the objects and an array, because after all in JavaScript everything is an object. Okay. Removing elements here by filtering is that removing from array. transforming an array, replacing items in an array, inserting into an array, making other changes to an array, updating object inside arrays, write consistent update logic with immer. Okay. So when we look at this kind of thing, especially updating object in a state and an array here, is that how replacing items in an array like this, like so, for example. Transforming an array, removing an array, inspiring sculptors, as well as this, adding to an array. When you push that new element to that, but you can set that artist to this. But you don't want to mutate the array. In fact, you want us to create a new array for that. By find that. But here you want us to use is a spread operator. Filter returns a new element. Exactly. So transforming an array. Replacing items in an array. Inserting into an array. Okay. And making other changes to an array like that. So the idea of looking now at this, okay, is that so the idea of looking now to recap it, which is something that I'm going to after this, is I'm about to write this Trello clone. I'm gonna do this as a way to see not only how can we build that from the composition way of React, or thinking in a React way, but also put a practice is the CSS skill. It's a way to create this layout, and also and also is how can we now work with states in our React components. So, okay, using is the data here. All right. So after we look at this, how can we now update objects or updating objects and array in a state? And how when anytime we talk about nested object, this is an incorrect way to tell, because after all, objects, nested objects, they are just different objects that point to each other. This is a different object that points to each other, that points to something. Okay, as I mentioned here. So they are just object. They are separate object pointing at each other's with properties. That's when we talk about that. It's like the different objects that are pointing to each other's property. Okay, so this will cause some ripple effects, which is the reason why we have solid principle. Because now if you come from object-oriented programming like Java, most likely Java, you now know is that how to actually write this application. So these kind of principles that Uncle Bob come out here, it was that to describe, hey, by using this particular approach, we'll make our applications much more easy to maintain and extend. Single responsibility, open to modification, close to extensions. If you want to extend that using subclassing, then let now your child class be able to replace the parent class, as well as yeah, as well as the be able to segregate. This is known as the list substitution. Okay, so when you're subclassing, the child class should be replaced with the parent, and when you want to expose objects to consumers, instead of throwing them everything that you got, so only expose the necessary interface for them. So this is known as interface segregation. So only show them the relevant interface for those users. A good example of that is when you in your stove. Well, you have a particular interface that allow you to do something. Okay, they don't throw you even the gas if you use gas, or the electric connection for that. No, they're not exposing that. That is not relevant for you. I mean, it is, but for cooking, that's not relevant. So that's one of the things of this interface segregation. And the other is that low-level dependencies or high-level high-level models should not depend on low-level dependencies. Should not import them. Rely on abstractions, not on concrete. So that's one of the reasons why we always generate is a new state from that. With object, we use a spread operator, and when we working with collection of elements like an array, we say, all right, we're gonna use this object that allow to always return is a new array from that. If you want to add a new element, you're gonna use is the previous array with now the new element that you want to add, whether it's at the front or the bottom, the front or the bottom. If you want to remove an element, you find them, and now one of the great things of the filter here, filter and be an array, is that it returns you a new array, a shallow copy. It means that only at one level. The method array instance create a shallow copy of the portion of the array filtering down. In other words, is that allow you to now give you a new instance of this property that follow that predicate, that follow that instruction. So this is now how can we is this is now how can we is not only adding elements to an array, removing elements, transforming an array. Hey, let's gonna find that element in a map, and if that match certain condition, I'm going to transform that. For example, we also look at how can we replacing items. There is like, hey, I want you to now again iterate through that map, or iterate through that, or to transform or to replace items in an array. Okay, but also always return is a new state of that, even though for inserting, which is quite more like that. You can insert them in a particular order, or pretty much like this. Instead of doing that, you just add this at the beginning. You can also add this at the end. But again, this may making other changes to an array. Okay, so for example, hey, I want you to now reverse this or apply our other elements. This will lay out the foundation, especially when you want to work is with now more complex state. When you want to build is, for example, a Trello clone, a Jira for that. It's like, oh, now it makes a lot of sense. Now it makes a lot of sense. So updating object inside of an array, as it is, you can actually do that. So you create these new arrays, and then you're going to find that in artwork that scenes is equal to the next scene. Exactly, and once you find that element, you get that, and then you're gonna pass that for this. Okay, okay, you are actually is finding that you're never mutating that state, okay? But with find you mutate that, return the first element. No, it means that exactly, this is not the way how you do that. You return as a new state, and inside of that, this is how you do this. You create a new copy of that. Exactly. So then I look at now how can we is managing our state, and this is now when we want to scale our applications here. Okay, so when we want to scale our applications, okay, when we want to scale our applications, how useful is for us to starting to understand how now to think in the React way. So I'm gonna take a quick break here before I move on. Before I move on. We are back, we are back, we are back. In this case, let me actually do this. We actually do this. All right. All right. And here we are. So, because after all, what we care now in this next topic is to see, is to see how can we after we look how can we how after we look at how can we describe the UI, and then how can we add interactivity to this UI, and as a way to show now relevant data and how we need to actually is to update the state as a way to trigger a rendering mechanism that is something that is taken care by React. This is this assembly line that it goes through the trigger, render, and commit. Okay, and then when it comes to update your state, how useful and how important it is for you to understand what will happen with your state during that rendering state as a snapshot, and then how can you now queue a series of state updates when you can do that to cover a very fairly uncommon use case, and then when you want, then how you can now updating your objects in a state. The TLDR is that always return is a new object. Avoid any deeply nested objects, because what happening is this is an incorrect way to call this deeply nested object, because after all, they're just different objects that has a reference to the common properties in an object. So because of it, and as a way to prevent this way of mutating that object, because after all, that's what now React cares about, is to generate a new state of that, as a way to prevent some common issues when it comes to mutate your state, which is might go beyond the scope of the work, but it's also to understand that how, for example, solid principles is something that allows you to create, manage, and maintain your object-oriented programming. And what object-oriented programming is, again, this is a particular way of how can we organize our data and our functionality together in one single place. Okay, and then how can we now managing our states? Okay, as a way to first look at now what is the main source of problems, especially when you are creating your application, and as your application grows, when you're adding more UI elements here and there, it is important to know how to organize your state, how to make the state update logic consist and maintainable, as well as how you can pass now data to distinct components. So by looking at this, by avoiding redundant and duplicate state, which is one of the common source of bug, we look first at how now React, how can we react to input with state, as a way to now allow us to create our user interface. This user interface that takes account borrow from the UI designers when they create their mock-ups, and they create all of these different visual states. And because the way of how we can create our UI before React is using this imperative approach, document get element by example. You're going to create a password. with the input at the bottom, and you want to add the functionality to say, hey, on mouse over here, you want is now to on mouse over, so on the mouse down, so you want is to actually here is on mouse over, on mouse over, you want to now actually is or on mouse down, sorry, on mouse down, I want you to now show the password, and on mouse up, show that obfuscate visual. So to implement that, we say, hey, document get element by ID of the input, and then let's go into hold a reference to the element. When we detect an event listening on the click, we go now to use this reference and update that property, which is the type, to password, or toggle between that. A password text, password text. So the whole point of this is that because this works well, when it comes to actually describe now more and more and more interactivity or UI elements with interactivity, it becomes quite hard to maintain. So React, the software engineers from Facebook say, hey, you know what? It'll be great if you can now use this particular approach, the declarative approach, which means that you don't take care of what's going on. You just want to build this, okay? Pretty much when you get into a taxi cab, when you say, So pretty much when you get into a taxi cab, so instead of you telling exactly which street you need to turn left or turn right, okay, you tell now the driver, Uber, hey, this is where I want to go. I want you to take the fastest route possible. It'll be good for you because now we set this fixed rate that I'm gonna pay for you. So you can now is dedicate your time to, well, receive and more passengers. So the idea here is that with that analogy, looking at how you can react to input with states as a way to see, identify all the different visual states that this component can have, then determine what triggers those state updates, so you can now represent those states using use state in memory, eliminate any non-essential states, and then connect the event handlers to set the state. This process is a mechanical process that you're gonna do anytime you want to create a user interface, okay? And again, for mechanical stuff, this kind of recipe works. But when it comes to live your life, go beyond the scope of the word. But in any case, so reacting to input with state, okay? And now how can we think is in terms of what'll be all of the different visual state that this component can be and must have, okay? So for example, thinking in React here, like so, breaking the UI into a components hierarchy, and like this, okay, you start with the mockup, exactly, but imagine that you have the structure and the mockup from a designer, right? And this is pretty much interesting because they already give you the data, they already give you, they already give you is the visual state, they already give you is the, this is what you're gonna do here. And the idea here is that with the AI, you can do this much more faster. So you don't need to actually more junior developers to get in, and all of those junior developers must to keep up the pace. I'm sorry that you didn't like it, but we tend to organize market people into places where they are cheap, when there is quality and good price. We always are drive to that. That's part of our nature. That's part of our nature here. That's completely part of our nature. So this is the way how they describing. Hey, here's the okay. That makes a lot of sense. It's like, hey, and I'm going to build this. I'm going to build the trailer clone. Is that, hey, here's the data, here's the mockup. How you can now represent is this drag and drop ability here. How you can now represent this drag and drop ability here. Interesting. So you start with the mockup that you should receive from the that you should get the data and the UI from that. Okay, so you want to now render all of this element here. So here's the step first is break the UI into components hierarchy. So you have now the search bar. You also have the product list, the product items like this. Okay. You have is the search bar. You have the product. You have now the list items here. Okay. That you want to show. And then you're gonna break down the UI per that. Okay. You're gonna break the UI into component hierarchy. In my case, I call this a search bar, the product tables, the list item. Okay. The product category and the list item here, followed by the entire state that will be managed this filtering product table. So when you break down the UI, now it is time to build a static version in React like this. And then find the minimal but complete representation of the UI. In other words, that don't repeat yourself. The original list of products, the search text the user has entered, the value of the checkbox, the filter list of products, which of these are states. And what you need to identify is which of these has state. Hey, does it remain unchanged? Does it remain unchanged? That's not a state. If this is passed, does it remain unchanged over time? This is not a state. Okay, so do we have to remember this data? Okay, or this is remain unchanged? That's not a state. Is it is passed from parent via props? This is not a state. Can you calculate that based on its props or on its states? Definitely isn't in a state. So what left is probably a state. So the original list of products, the search text the user has entered, the value of the checkbox, the filter list of products. So the filter list of products is something that changes quite over time. So the filter list of products, the value of the checkbox is in a state. The search text the search text the user has entered, the original list of products. That's not a state. Hey, this remain unchanged over time. It's not a state. So the original list of product is passed as prop, so it is not a state. The search text seems to be a state since it changes over time. The value of the checkbox seems to be a state because it changes over time. The filtered list of product is in a state because it can be, okay. The filtered list of product is in a state because it can compute it by the original product. So this means only the search text and the value of the checkbox are states. Nicely done. So props versus state, and then identify where your state should live. And here is when you take a look now at this particular concept that we're going to talk about. That first we'll look at reactive to input states, and then how can we organize in state structure, choosing the data structure. They come out with some principles, React, as a way to say, well, I prefer to put this light, okay, as a way to say, hey, group related states together, avoid any contradictory states, avoid any redundant state, avoid, and redundant is that, can I get this data from other states? So for example, here, okay, the filter list of products, can I get this data from other states? Okay, avoid any duplicate data. Avoid any duplicate data. Yeah, avoid any duplicate states because they're hard to keep sync, and also is avoid nested object in your states. Why is that? Because you're gonna hold reference into that, and they become quite hard to keep track or to sync, to update. So you don't want to do that. So we also look at how can we do that, okay? And when it comes now to identify which state do we need to share across different components, okay? It's important to, which is something that we can do, for example, sharing state from different components by passing down now the state followed by the handlers to these child components. And when this child component actually is trigger those state updates, well, we actually now emit that function that we receive as props. So we can now show is the proper state for that. The whole idea of this is that when we're able to now sharing a state across different components, it is important to think of them, which is something that they mention here. Okay, it's important to think of them as like so. So control and uncontrolled components is that when writing a component, consider which information should be controlled via state and which information should be which information should be controlled via props, and which information should be uncontrolled via state. And you can always refactor that. The idea of doing that is that with the uncontrolled and controlled components, when you want to create is a form, you can do that in the uncontrolled way, where it is much more better to rely on the behavior that the browser allowed us. So for example, here. So now, it's on the React, intermediate React, no. And React intro, a complete intro to React. That's right. when Brian Hall is talking about this uncontrolled form and that kind of thing. This is known as uncontrolled form. When you're defining your state, and it's in here where you set that things for us. So the way of how this is actually an antipathy. You shouldn't do this. This line has our own query here from that. Exactly. Here, this is a way of how you can now use is the uncontrolled form component, and how solutions like React hooks come up and say, hey, wouldn't it be better to actually use this form as a way to handle that? So when you now use is a hook for that. You know, is making less verbose anytime you put that. It's making less verbose when you put that kind of thing. And isolated re-render. Supporting and backed by powered by Vercel and Casino this. Casino reviews. And Redux. How to play the best casino game. Poker, blackjack, baccarat. Instance, minimum transaction 10, and the tailoring, all of this kind of thing. In Philippines, Switzerland, Spain, Canada, US, Vietnam, UK, Thailand. Why I'm not surprised, man. Why am I not surprised? And the type of payment here, even Bitcoin, that kind of thing. Anyway, this is an industry. It's an industry that is powered by this. So yeah. You can have subscription for that kind of thing. Okay, anyway, but the idea here is that once we look at this and how important it is for us when it comes to describe the your components and its capability, which information, when writing your component, which information it should be controlled, okay, via props, which information should be uncontrolled via state, as a way to know uh, defining is defining the capability of these React components. Okay, defining the capability of these React components. In any case, so I think this is quite interesting, because now when we're able is to put that this piece of information which will be controlled is control, meaning via props, or it will be in control via its state. So when you decide which components or when you choose which components owns this unique piece of state, now you're making these components the source of truth of all of the other components that comes before or coming after this, the child component. And that's now the core value proposition of Redux, as a way to now have this particular state, this particular information app level state, that when you need that, when you want to read that, you can do that using is a subscriber, or you can is subscribe to that. Okay. Okay. No. Okay. You can is subscribe to that. Maybe this is a store. Use selector, that's right, which is a hook. Hey, I want you to now read of this. Well, I'm gonna use selector as a way to now pass the proper state for that. Okay. Use app selector, okay, which was a hook that must be defined here. And the particular store state that you want to make access to that, which is when we look now at the intermediate React 5. Okay, which is this introduction and hooks in depth, specifically with Redux, right? Specifically with Redux here. We look now at how can we not only create our slice, but also how to store data using this patch. Okay, use this patch from Redux, and reading the state using the selector by actually is importing that store from that. path provider, search pattern. That's right. And how can we now Borderland reducer and redux? Borderland ref, no. Of that state where it allows you to access to the proper where now this is okay, receive this so the use selector exactly is now, it has this callback function here of the state for that allow you to now access to that particular slice and it is value. So in our case, we got the adopted path and the search pattern followed by the property here. Or in the model, so the idea of looking at this is because now it makes a lot of sense when you are now being able to describe these particular sections as a way to say, okay, when you're managing your estate, this for clarity, I'm doing this is for clarity. When you need to manage it is your state here, okay? So when you need to manage your state across different components, it's important to, when you're going to describe your React component, hey, is this information will be controlled, meaning via props, or it'll be uncontrolled via state. And when you choose which components own this state, now that will be act as the source of truth for all of those child components that have access to. So as we move on of this concept of single source of truth, which is part of the way of how you can start to thinking in React, okay, followed by how now the state is preserved uh, in your components. And when you talk about preserve here, they don't make any reference about the here they don't make any reference about that. It's in the position of the UI tree, not on the GSS markup, which is preserving the state here. All you see is the tree you return. When you render a different component in the same position, it resets the state of its entire subtree. If you want to preserve the state between re-renders, the structure of your tree needs to match up from one render to another. Which means here they don't actually is describing is this. But they don't mention here anything related to the virtual DOM. For example, like this, the virtual DOM is a programming concept where an ideal or virtual representation of the UI is kept in memory and synced with the real DOM by a library such as React DOM. But in this case, the virtual DOM is a programming concept that holds the ideal or virtual UI representation and escaping memory and sync with the real DOM. So the React DOM actually do that. This process is called reconciliation. This is now when we're talking about now at the commit phase, right? At the commit phase. Because now that we know that the trigger is when it detects when a state update happened, the render is when it evaluates is or call those React components, so it computes out of its problem state and event handler, store them in a state or store that information to be later on use it on the next phase, which is the commit phase. And on the commit phase is like, this is when now React here, okay, this is now when React here, let me see this. Yeah, this is when now React will apply the minimal necessary operations calculated by while rendering to make the DOM match the latest rendering in output. Okay, so to make that actually happen as it is, so for re-renders, React will apply the minimal necessary operations. React only changes the DOM now if there are different between renderings. And you may wonder how that works. Oh, thanks to the reconciliation phase. So this approach enabled the declarative API of React. You tell React what state you want the UI to be in. What state the UI you want to be in. Okay. Hey, this state is in this UI element, in these React components, and make sure that the DOM match that state. This abstracts out of the attribute manipulation, event handling, and DOM updating that you will otherwise have to use to build your app. Since the virtual DOM is more a pattern than a specific technology, people sometimes say it's different. It means different things. In React world, the term virtual DOM is usually associated with React elements, which is with create DOM. With React elements. Exactly. With React element here. Since they are objects representing the user interface, React, however, also uses internal object called fibers. So the virtual DOM is more a pattern than a specific technology. Okay, this is a pattern of how can we now represent is the ideal virtual UI to keep in sync with the real DOM. So we're gonna using a closure. Makes sense. I'm assuming this. Okay. So, but the VDOM is a conceptual, is a programming concept where this ideal or virtual representation of the UI is kept in memory and then synced with the real DOM by a library called the React DOM. So the virtual DOM here, okay, is more like a pattern that allows you to tell React what state you want the UI to be in. What state you want the UI? Okay. What state you want the UI to be? As a way to keep track of this, as a way to keep track of which state the UI you want to be. So just like taking a snapshot of a UI state. So this abstract out of the attribute manipulation, event handling, and DOM updating that you will otherwise have to use to build your app. So in React world, the term virtual DOM is usually associated with React elements, since they are objects representing the user interface. That's right, this React element, okay, or this React components, okay, since they are, which is they are just JavaScript functions that allow you to return is this. So unlike browser DOM elements, React elements are plain objects. Okay, React elements are plain objects are cheap to create. Okay. And they are cheap to create. Okay. React elements. And by React element is writing markup with JSX. This is JSX. Since they're objects representing the user interface, React, however, also uses internal objects called fibers to hold additional information about the component tree. So these fibers, okay, are internal fibers, are internal objects that React use to hold information about the components tree. They might also be considered a part of the virtual DOM implementation in React. Because this virtual DOM is a pattern, more like a technology, where it represents the UI, it represents the ideal UI in memory that you want to keep sync with the real DOM. Because this virtual DOM is usually associated with these React elements, rendering elements, exactly, because this virtual DOM is usually associated with the React elements. These dogs are all elements, are a smaller building block of React. Unlike browser DOM, React elements are plain objects and are cheap to create. This. Okay, because they are function here. Okay, so because they are function here, okay, so the term virtual DOM is usually associated with React elements, with React components. Since they are objects representing the user interface, since they are functions representing the user interface, React, however, also uses internal object called fibers to hold additional information about the component tree. So these fibers contains additional information about the components tree, because at the end of the day, React needs to keep track which UI state changed so they can apply the bare minimum necessary DOM updates. So this fiber is part of the virtual DOM, which now holds this additional information about the component tree. Is a shadow DOM the same as the virtual DOM? No, they are different. The shadow DOM is a browser technology designed primarily for scoping variables and CSSing web components. So shadow DOM is different from the virtual DOM because it is designed to scoping variables and CSSing web components. The virtual DOM is a concept implementing by libraries in JavaScript on top of browser API. And what is React Fiber? Fiber is the new reconciliation engine in React 16, and its main goal is to enable incremental rendering of the virtual DOM. So this React Fiber is allowing this incremental rendering of the virtual DOM. React Fiber is an ongoing re-implementation of the React core algorithm. It's a culmination of over 2 years of research by the React team. The goal of React Fiber is to increase its suitability for areas like animation, layout, gestures, and gestures. Its headline features is incremental rendering, the ability to split rendering work into incremental rendering. The ability to split rendering work, or in this case, calling functions into chunks and spread it over multiple frames. Okay, I have now the ability to split this work, into multiple frames. Other key features including the ability to pause, abort, and reuse work as new update comes in, the ability to assign priority of different types of updates, and a new concurrency primitive. This is not an official document. I have asked members to the React team to review it for accuracy. This is also a work in progress. Fiverr is an ongoing project that will likely undergo significant refactors before it is complete. My goal is that after reading this document, you will understand Fiverr well enough to follow along as it is implemented. Prerequisite. I strongly suggest that you're familiar with React components, elements, and instance. Lol. Reconciliation. React basic theory concept. Transformation, abstraction, composition, and state. A UI is no simple replication of server business logic. And you are returning a function like this. It is a closure behind this. Implementation details. And fancy name box model. This example uses side effects to update state. My actual mental model of this is that they return the new version of the statement. Memoization. Less continuations. State map. Memoization map. Algebraic effect. How old is this? 8 years. Oh. Respect, bro. And then React principles. Pay special attention to the section on scheduling. It does a great job for explaining the why of React Fiber. What is a reconciliation? The algorithm React used to diff one tree with another to determine which part needs to be changed. Update a change in data like this. Reconciliation versus rendering. The DOM is just one of the rendering environment. React can render to the other major targets being native iOS. And scheduling. And what is a fiber? Structure of a fiber, type and key, child and sibling, and return. Pending props, memoize props, pending works, priority. Design principles. Yep, design principles. Okay. But the idea here is that understand what is the okay. The other link doesn't work. React basic theoretical concept. Okay, a description of the conceptual model of React without implementation burden. Some of this may not make sense on first reading. That's okay. It will make more sense with time. Reconciliation. Exactly, several page not found at React Fiber architecture. Prerequisites. At React Fiber. Prerequisites. Yes, several page not found in prerequisite at React Fiber architecture. To virtual DOM and internals. Out of the four, three out of four prerequisite are not working. Doesn't work. Mm-hmm. Exactly. Okay. Mhm. The transformation here. What you're now creating is a closure for that. In an state memorization state map, memorization map, and they can say algebraic. Okay. 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 Perhaps we are now as diminishing the return of value of this. It's like chill with this. Chill, 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 chill. Because now that we look at this and how can we manage our state, and especially here when you are now is preserving and resetting the state here as a way to now React keep track of which state belong to which components based on their place in the UI. How React does it? What is the mechanism? What is the name of the mechanism here? reconciliation, to keep track which state belongs to which components, which is reconciliation, like this. So the process of now, so the process of, because it's a process, a pattern, it's not a specific technology. So the process of, okay, this commit phase. So the process of having a virtual DOM, which is an ideal representation of your DOM in memory to keep sync and sync with the real DOM, okay, this process is called reconciliation. This process is called as reconciliation. So React provides the class, and that's one of the reasons here when you talk, when they describe in this, like so, it's like preserving and resetting the state, because React keeps track of which state belongs to which component. Because React keeps state, because React keeps track of which state which components belongs to. Okay, on their place in the UI, you can and they do that by a process called reconciliation. The diffing algorithm. When diffing two threes, React will compare the two root elements. The behavior is different depending on the type of the root elements. The diffing algorithm. So this is the algorithm that it used to reconciliate that. It enables efficient updates and reduces the work need to reflect the change. It enhances the performance by updating only the required components node and resulting in a fast response while changing by reducing the unwanted and unnecessary re-renderings. Diffing algorithm is React differentiates the update and previous DOM of the application. DOM store the component, but it's because React has the ability, and it's because React keep track of which state belong to which component in the place on the UI using the reconciliation algorithm as a way to look at now what are the as a way to look at now what is the difference between two render tree, okay, and then apply the necessary DOM updates to that. This approach enables the declarative API of React. You tell React what state you want the UI to be in and make sure that DOM match that state. And make sure that DOM match the state. And the shadow DOM is a browser technology that is designed primarily for scoping variables and CSS in web component for scoping variables and CSS in web components. Because after all, CSS is this cascade nature, and that actually is problematic when you have to handle large code bases and someone put an import somewhere, right? And then you want to actually send in a reason. It's like, why'd you put that an important? Okay. So the virtual DOM is a concept implemented by libraries in JavaScript on top of the browser API. on top of the browser API. It's a concept implementing on top of the browser API. But this is now makes a lot of sense. What React Fiber is, React is the new reconciliation engine. Interesting. So when we talk about is the React rendering phase, okay, which is this rendering mechanism. When it passes through the trigger and rendering on the commit phase, where it applied the necessary down updates to that, React behind the scenes has a implements this pattern called the VM, the VDOM, which now store in memory the virtual representation of the ideal DOM and sync with the real and sync the visual representation or the virtual representation of an ideal DOM and then sync that with the real DOM. So this process of syncing is known as reconciliation. And this process of reconciliation uses the different algorithm. So now React Fiber is the new reconciliation engine in React 16. Its main goal is to enable incremental rendering, incremental calling of functions. Hey, I'm going to call this function, and there's another function, the incremental calling functions of the virtual DOM, of this representation of this. Okay. 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 So what we're talking, all right. All right. So, why this is important, you may wonder. Why this is important? Because now, this is what React is using behind the scenes as a way to keep track of all of these components that you define there, followed by it is a state, and now it keep track of that. And the way to do that is using the virtual DOM. That is not a technology, is a concept that now JavaScript frameworks implement. That now JavaScript frameworks implement. So for my question is that is Vue use a virtual DOM? Rendering mechanism. How does Vue take a template and turn into actual DOM node? How does Vue update those DOM efficiently? We will attempt to shed some of the light of this question here by diving into the Vue internal rendering mechanism. Behind the scenes, Vue is using the concept of React, and all of them are just shuffling. You have probably heard the term virtual DOM, which means Vue rendering system is based upon. Because virtual DOM is not a specific technology, it's a programming concept that is being used by JavaScript libraries, React, and Vue, for example, as a way to now store in memory the ideal representation or the virtual representation of the DOM and sync with the real DOM. And by syncing that is using a process, and the process of syncing this is known as reconciliations. The using is the different algorithm in the React system. But now React Fiber is this rendering, this reconciliation engine that aims to now make incremental rendering. That enable incremental rendering of the virtual DOM. It means that I'm going to update this virtual DOM incrementally. It means it's improving. Okay, it is improving the way how now React or any of these libraries that use this programming concept called the virtual DOM as a way to hold is an ideal of this virtual representation in memory of the DOM and sync with the real DOM and do that in the and commit those state change and commit those change and make it minimal exactly, and make it incremental and enable incremental rendering of the virtual DOM. But there is the React Fiber. Is the React Fiber the reconciliation? Is the React Fiber the reconciliation? Yeah, is there what is it? What do you want to know? Is React Fiber the reconciliation algorithm? Or is it a reconciliation process in React 18? Yes, React Fiber is in this closely related to the reconciliation process in React 18. To clarify, React Fiber is not exactly the reconciliation process itself, but rather the internal implementation architecture that enable efficient reconciliation, introduced in React 16 and refined in subsequent versions, including React 18. Fiber reimagined the core algorithm React used for reconciliation. React 18, Fiber continues to be underlying architecture that powers the reconciliation with some enhancement. It enables concurrent rendering features. You can now concurrently is calling this function, these React components. It allows for prioritization of updates. Now we have here of the the low priority and high priority renders. It improves the ability to pause, abort, and reuse work as needed. The reconciliation process in React 18 uses Fiber architecture to perform this work more efficiently, allowing for features like automatic batching and concurring, allowing for features from automatic batching and concurrent rendering. Would you like to more? Okay. So React Fiber is not the implementation, is not a reconciliation process, but it enables efficient reconciliation. It's an internal implementation architecture. It's an internal implementation architecture that makes the reconciliation efficient. Okay. As a way to make the reconciliation, it all starts here by when you are now sharing your state across different components. Okay. So when you do that, okay, each unique piece of state, you choose. You will choose which components owns this, and when you do that, okay, you're not only telling to React that this state belongs to this UI component. Okay, that now things started to make a lot of sense. Okay, okay. Like this. Okay. So, so when you tell React, okay, 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 okay. Oh my God. React rendering. Okay. Okay. Keeps that update logic maintainable, and the other is the uh, state preserving and resetting a state. Preserving and resetting. Resetting the state. Okay. Okay. Once exactly. So once you create your React component, each piece of unique states you will choose. God damn it. Each piece of unique state you will choose which component owns it. Which component owns it. Which components owns it. Meaning that React will keep track the state because it's like a React keep tracks which state. Okay, meaning that React will keep track which state is associated to which component, or which state belong to which component. Okay, which state. Okay, meaning that React will keep track which states. Meaning that React will keep track which state, uh, which state belongs. Okay, meaning that React will keep track which state belongs to to which which component, to which components. How React knows that, or how React keep track of that. Okay, how does React knows that? So if I ask here to this, so meaning that React will keep track which state belongs to which component. How does React know how to keep track of that? Components instance, fiber nodes, tree structures, unique identifier, reconciliation, state preservation, and key of list. For dynamic lists, you provide keys to help React track individual items across the render. Mm-hmm. Mm-hmm. So I just want to start a new conversation. Since React mm-hmm. Okay. Why this is important? You know, why this is important? Meaning that React will keep track which state, meaning that React will keep track which states belongs to which component. Uh, so in the render, so in the commit phase, okay, So in the commit phase, React will know which component uh, uh, okay. So meaning that React will keep track which state belongs to which component. How does React know to keep track of that? How does React know to keep track of that? Because so once you create your React component, each unique piece of state you'll choose you'll choose which components owns it, meaning that React will keep track which state belongs to which components. So how does React keep track of that? Of that relationship, of that tracking mechanism. Yeah, how does React keep track of that to update the necessary DOM DOM elements? So using the virtual DOM. Okay. So using the virtual DOM, which is a programming concept to store in memory the ideal representation of the UI and keep it sync with the real DOM. When a state change using so when state change so when the state change, React keep it sync thanks to the reconciliation process. React Fiber is part of the architecture that allow this process to be more efficient. That allow to this process to be more efficient. Thanks to the reconciliation process. So React Fiber is part of the architecture that allow this process to be more efficient, which enables things like state or series of state updates. Series of state updates. It allows concurrent rendering features, which enable things like concurrent rendering features. So we can now call our React components in parallel. Okay, we can now call our components in parallel. Concurrent rendering features, prioritize rendering, prioritization of updates, prioritization of updates. Okay. Prioritization of updates. Mhm. Yeah, prioritization of updates and the ability to pause, abort, or reuse work as needed. The ability to pause, use. Mhm. The ability to pause and use. Yeah, um, the ability to pause, abort, and reuse work as needed. Okay, but again, all of this is just to describe that at the end of the day, the virtual DOM is being used for the JavaScript library on top of the browser API as a way to store, oh my god, as a way to store is in memory this virtual representation of the DOM, ideal DOM representations, and keep it synced with the DOM. And the way how it keeps sync is through the reconciliation process. React Fiber is part of this as a way to now allow you to is concur, enable concurring rendering features. Okay, so now you can is calling this function concurrently. Prioritization of updates, you can say, hey, I want you to now uh, first update this and then the other ones, and the ability to pause on this again. That's quite interesting. That's very, very, very interesting, because now that leads us to understand truly that since React keep track of which state belongs to which component at the and it does that at the at the position of the UI, thanks to the virtual DOM, these virtual representations of the uh, this virtual representation of the ideal UI that keep in sync with the DOM, and anytime you update that, okay, React will gonna pass through this rendering mechanism, the trigger rendering, and then the commit, which is the reconciliation process, where it applies the bare minimum DOM updates like this. Okay, React only changes the DOM node if there are difference between rendering. So when he compute that, when you update the state, it will go through that component that caused that, or at the initial render, and then evaluate, and then evaluate that. This process is recursive. Is the updated React will call the function whose state updates trigger the rendering. This process is recursive. Is the update component returns some other components, React will render that component. It means it is gonna call them, and if that component also returns something, it will render that component next, and so on. And the process will continue until there are no more nested components, and React knows exactly what should be displayed on the screen. So React all so after rendering, calling your components, React will modify the DOM. It's in the commit phase where React is going to now modify the DOM, meaning since React keep track of which state belongs to which component, and when you set an state update, it will trigger the rendering mechanism, trigger the rendering, aka calling your function components, and then the commit phase is here when after the rendering, after calling your components, React will modify the DOM. React will going to update the DOM using the virtual DOM. And the virtual DOM is this programming concept that JavaScript libraries are used on top of the browser API as a way to now reconciliate, which is the process they use, with the virtual DOM, with the real DOM. Sorry. So this virtual DOM, which represents the ideal UI that you store in memory and you keep sync with the browse with the real DOM. So now React, when detect that state update, you will know which component needs to update. So as long as they are different between rendering, between different components. But that mechanism that is using behind the scenes is this reconciliation process. And this reconciliation in this reconciliation process, which is using the diffing algorithm as a way to identify which elements are different in a tree. So React Fiber is part of the reconciliation process that allow us is to have now prioritization of state updates. We can now rendering we can perform concurrent renderings, concurrent rendering features, which means that we can call this component or this series of components in parallel, increase the performance of and the efficiency of this algorithm, prioritization of updates, and the ability to pause, use and abort work as needed in pass. That's the role of the virtual DOM. What is the difference between the virtual DOM and the shadow DOM? The shadow DOM is used by web components to scope variables and CSS. Okay. This is a browser technology. So the shadow DOM is a browser technology designed primarily for scoping variables and CSS in web components. Okay. All right. Okay. So now we understand what is the mechanism that happened behind the scenes during the commit phase. At least we can describe that, and then we have now a sense for that. So when we're describing here, for example, sharing a state between components, okay, and how important, when you define each piece of state, you will choose which components owns it, meaning that it will become the source of truth for any other children component that make use of it. Which means that concept like Redux makes a lot of sense. You have now single source of truth. You have the app level state data for that. And because React now keep track which state belongs to which component, part of the as a way to now make efficient DOM updates, okay, we look at how it actually works when it comes to how that work. Yeah, how that work. We're working with React components, okay. So how we look at how that work when working for the developer perspective as well as the inner mechanism. So for the developer perspective, or from the dev perspective, is you can React will preserve the state at the React will preserve the same components. React will preserve the state of the same components in this. Sorry. React will preserve the same. React will preserve the same components. React will preserve the state of the same component if they are in the same position in the render UI. So, if you want now to, React will reset the state if there are different components in the same UI position. If you, for example, wanted to reset the state of the same component at the same position, you can or render that in a different position of the render UI, or of the render UI, important here, of the render UI, not on the GSX position, not on the GSX position, so here it will render not on the same. Okay. Even though that we're using div and selection, they actually will work here. Oh no, but they won't, because now you have different element. Exactly. If you want to preserve a state between re-render, the structure of your tree needs to match up. Okay. If you want to preserve this, okay. The structure of your tree needs to match up. This is what you should not nest component functions definition. Exactly. This is what you should not nest component functions definition. Oh, exactly. It's a way to nest. Oh. I get it. No. You should not nest function components definition. So what happened here is that it won't trigger is a counter. Okay, but it won't update the text here. No, it's updating that. But every time you click the button, the input state disappear. Oh, because it's resetting the state. Because it rendered that, and now it reset the state. It's because there are different components at the same position. It reset the state. You're rendering a different component in the same position. You're rendering a different component in the same position. This leads to bugs and performance problems. To avoid this problem, always declare a component function at a top level and don't nest their definition. So that will lead us then to actually understand is that how. Okay. So then that lead us is to understand that, all right, how now this, how can we now keep up the state update logic consists? How can we keep our state update logic is maintainable using reducer function? And to me, this concept was more straightforward to grasp on rather than the other, because it was less visual, and I am visual. Peter, I get it. I am visual. 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 I am definitely visual. Okay, all right, okay, cool, cool, cool. And that leads us is to understand that how you can use Reducer. Okay, what is the main use case for Reducer as a way? The more input that this state needs to react, the more it makes sense to define all of this state using Reducer, a state update using a Reducer. Using this hook of the Reducer state, that makes sense. So don't overuse Reducer. Again, this is the rule of thumb of Reducer. The trade-off is that even though that it increases the code verbosity in our components, it also now make our state update logic easy to test and debug, which are two things that I really love. Easy to test, debuggability, and easy to read. All right, that's all. So, then we also look at extracting a state, the extraction state with a reducer. How can we now pass data to distant components as well? And using now context, which before using this, or you pass the component through the props, or you extract that GSS component and then pass that data to that. If that doesn't, if that's not a good way to put it, or if that doesn't work well, then you can use context, because the context, what it's doing is to prevent this thing called props drilling. When you pass a lot of this data down to distant child, and if any of these elements are removed, what happens is that you break the data change. So to prevent this, we have now this particular store here, or this context, where we create a context which represent is a which content can use or provide. So the context it represent is which components. Context represent which context other components can use and provide to this. So by creating our context in a particular file, using the create context from React, which expose is the consumer and the provider properties. So you're gonna use your context in the component needed. You're going to provide the context one level above or at minimum. So now this provider, or now this data can be accessible through all of the sub-tree elements. So this is great, for example, to make your React components aware of its context. For example, theming. So you put it here, you just only change this particular flag. And now all of these components are capable is to react to this, okay? And to adapt to the surrounding. Another is, for example, authentication, where you put your data from the user data and then you make that available to all of that. Another good use case is for the React Router library, where now you can know which URL the user is currently at when dispatch is clicked or when navigate to a particular link. And also, contexts are useful when you want to manage is your state update logic with reducers as a way to now make it much more easy to manage, to scale your state. So this is something that we look at the scaling with reducer and context, where in that particular file, the context file, we create the context for the state, the context from the dispatch. We define our functions where we're going to now use the reducer there by passing the reducer function to the states followed by the initial values. We right below the function that we're going to export, with our provider GSX that will contain is the data there. Right below we define is the reducer functions, okay? So, which is a function that takes a state and an action to generate a new bit of state. Using is the switch statement for that. And now on the export functions, where we're going to not only is make use of the state using reducer, as well as we're going to get this dispatch, we go now is to export is in the GSX, we're going to return is the provider from the state and then provider from the dispatch. So now in this function, we're going to take the children's props and pass that the props as a way to now make available to all of these other components that it needs to render, and then we can pass down that data to that. And I think this is something important to describe, because this is part of the core of how you can create this scalable React UI. Oh my God. So now it is time to put that at practice, my friend. Yeah. Totally. So with that, that'll be all for this video. Take care. Bye-bye.